All right, I want to talk a little bit about Lab 2 with the tuition calculation. We're gonna take a minute. In a minute, we're gonna look at the chart, the tuition chart for Lorraine County Community College's tuition. And I want you to notice some things. This chart is set up so that 1 through 12 credit hours is simply the rate for 1 credit hour times the number of credit hours. So 12 times 159.03 is $1,908.36. Now notice that something else happens when you hit 13 through 18 credit hours. You get charged a fixed amount. You get charged for 13 credit hours, regardless of how many credit hours you take up to 18. So if you take 18, you get charged for 13. If you take 15, you get charged for 13. And of course, if you take 13, you get charged for 13. And this is consistent, by the way. What I'm saying is consistent across all of the 3 categories. Then, once you get above 19, or above 18, you're starting with 19, you then add in each additional credit hour that you take. So for 19 credit hours, it's the cost of 13 plus the cost of 1 credit hour. For 20, it's the cost of 13 plus the cost of 2 credit hours, and so down the line. So that needs to be in your calculations. So your calculations are not going to be as simple as figuring out the residency code, figuring out the rate, and then multiplying the rate times the credit hours. You're going to have some logic in there to do if statements to determine exactly what formula you're going to use to come up with the tuition. So that was one observation I wanted to make, and I want to make sure everyone understands it. All right, now, the other thing that this has an implication is with testing. All right. If you test just one condition, you have no idea if your code is really good or not. For example, if I just tested 6 credit hours out of county and I got that amount, then my job isn't done yet. Let's think of how many students would have to test to be pretty sure that our code is correct. Well, we'll obviously have to test 3 different students well, that's our starting point. We're gonna grow the number from there. So we have to test 3 students, because we have to test a student that's in county, a student that's out of county, and a student that is out of state. Then, as we identified, there's 3 zones to this calculation. The 1 through 12 credit hour zone, where the calculation is done one way. There's a 13 through 18 credit hour zone, when the calculation is done another way. And then there's the 19 and above zone, when the calculation is done a third way. All right. Now, you might think that that would be 9. 3 zones of the tuition chart, 3 residency codes. And that's not a half bad answer, but really, I would want to test a few in each zone. I would want to test 12 for sure. I'd want to test 13 and 18 and 19. The reason I'd want to test that is because that's the borderline between the zones. Make sure my if statement is right, that it says greater than and not greater than or equal sign, or whichever one it has to be, it says the right one. All right, so I would test the borderlines between those 2 as well. Just like if I was doing an overtime calculation, I would test 39 credit hours, that is just below 40 hours. I would test right on 40 hours, and I would test above 40 hours. Testing is important. Because your program runs and gets a correct answer doesn't mean it's correct. And part of your job as a developer, we're doing these unit tests, is to do as good a job possible as testing it to ensure that there aren't any errors. So I will start taking off for testing. So if you're just testing one student or something like that, don't be surprised if you get points taken off, because it's important to test thoroughly. In the case of pizza, again, don't tell me I'm not practicing what I preach, because I do these examples in the interest of time. I do just one example, and it's part of your challenge to figure out what the rest of the example would be if I was going to thoroughly test this. But just to start, I have 3 kinds of crusts. No, I have 2 kinds of crusts. I have 3 sizes, so that's 6. And I have pepperoni, yes or no, so that's 12. So I would have a total of 12 different pizzas I would have to test. And, that's not that big a deal. I mean, you'd have to do some copying and pasting and do that, but that's not like a superhuman task to do. And you can easily do it. And then you'd know it was right for every single calculation. So you should calculate by hand what you expect the result to be if you buy a small pizza with thin crust and without pepperoni. You should calculate by hand what it should be. Then you should look at what the computer produces, what your Java program produces, and make sure that they sync up. In fact, we're not quite up to the point of doing it yet, but at some point in this course, we're going to develop test plans. And there can be simple and more difficult test plans. Let's just look for a simple test plan. Not really what I want. I think this is what I have a good example in a future week. Let me pull that up. Not able to find right off the top of my head an example I like, but I know I have one in one of the upcoming weeks. Okay, test plan can be simple as this, all right? What you're going to test, how you're going to test it, what result you expect, and what result you get. And I just realized I don't have a projector on. Should have let me know.
Sorry about that, Professor Sellers. I apologize.
Don't apologize. I'm the one that made the mistake. But in the test, you have what you're going to test, how you're going to test it, what result that you're going to get, you expect to get, and what result. So in the pizza example, it might be order a small thin crust without pepperoni. The test step to do that is create a pizza in the unit test code that sets the parameters of small, thin, and no pepperoni. The expected result would be whatever you calculate the price of the pizza should be, and the actual result would be what your program says. And it's just a matter, you check it, you don't check it. Now, you keep your test plan around. Why do you keep your test plan around? Because almost any code that you write is going to be changed at some point. And therefore, when you change it, you want to retest it. Now you might say, well, I didn't touch that part of the code. Why do I have to retest something if I've changed something else? Well, you do, because the way things interact, I've seen so many cases in my career of people that said, I've only changed this one little piece of the class or this program, and therefore I didn't see the need to test the entire thing. You do, because things interact sometimes in ways that we don't realize or that we understand, and therefore it's important to retest it. And if you have your test class, if you have your unit test written, to run your unit test every time you make a change ought to be pretty easy, right? Ought to be pretty straightforward to do. You have your test class, your unit test class with your test cases, and you run it and you make sure you're getting the results that you want. So this is important. And again, so for many people's assignment for lab 2, I said you needed more test data to make sure that it works. All right. Our next topic is going to be on array lists. Now, let me rewind for a second. Let's look back at Elsie's tuition. What if I wanted to test all of these? That's 66 test cases. Wow. Does that mean you have to copy and paste 66 times? Not necessarily. We could actually write a piece of code that loops through. How would we do that? We could do something like this. And I'm just going to write some rudimentary code. It's not going to be completely detailed, but just to give you an idea how we could test this. I don't want Visual Studio. I want Visual Studio Code. I could do something like this. I could do a for loop. And I could say for int hours equals 1. I want to repeat this as long as in hours, as long as hours is less than or equal to 22, let's say. That'll give us all 22 rows of it. And I want to increment hours by 1 each time. So this is the for next code to do that, for next loop to do that. And its syntax should be identical to C#. So what am I going to do? Inside my loop, I'm going to create a student. So I'm going to say student S equals new student. set hours to that hours variable. Set residency to, I'm going to hard code in county. Then I'm going to output now you would want to pretty it up and make it look a little better than this, but something like this. Just duplicate this for each of the 3 residency codes. And there's ways that you could get away with not even duplicating it. You could run another loop if you wanted to. Out of county, S2, S3, 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 S3. So you have something like this in your unit test class, and it will loop through for making the hours 1 through 22. Each time through the loop, it creates 3 students, and it sets their residency code, and it calls calculate tuition. So this loop will execute 22 times. Each time through, it'll output 3 students tuition, and in total, it will output the 66 test cases that you have to duplicate that chart. Now, one nice thing that you could do, you could actually duplicate the chart, more or less. And I know there's probably a better way to do it than this, but this is the way. It's the most straightforward way. And to make it more readable, you could output a row of dashes or underscores or something like that to underline and put an underline under each row. So if you do this, you could test all of them. All right. And you could essentially recreate the chart. You take your chart that was produced, compare it against the chart on the website, and you know it's correct. All right. The next thing that we're going to talk about, now we're ready to the next thing we're going to talk about, is when you have lists of items, when you have lists of something. For example, a pizza order. What does a pizza order consist of? Well, it consists of some information about who placed the order, like name, phone number, maybe address, other information perhaps. And then there's a list of pizzas associated with it, right? Every order is going to have, let's assume again that they only sell pizzas at this shop, but every order is going to be a list of pizzas. How many pizzas? We don't know. Could be 1, could be 15 if you're catering a party or something like that. We don't know how many items are going to be in that list. All right. In other words, the size of the list is dynamic. All right. For some, we're just going to have 1 pizza. For some, we're going to have 8 pizzas. For some, we might have 2 pizzas and so on. Now, in the past, we've looked at arrays. We've looked at arrays in Java, and we saw how to create an array. We did that in the very first lab with the Madlib. Now, the thing about arrays is they have to be declared at a certain size. All right. And you can't change the size once you declare it. All right. So if we have a Java array right here, this array has 4 elements in it. All right. We couldn't add a 5th car to that list. All right. Because when it's created, the size is set and you're stuck with it. We can change and we can access the different items in the array. We can get the length of it. We can do all those things, but we can't change the number of items in it. Well, that would be inconvenient for, say, a pizza shop, because how many pizzas would you allow to be put in the array? Would you have the array to have 3 spots for pizzas? It doesn't sound right, because, I've ordered more than 3 pizzas before, when I have a group of people together. Would you make it some ridiculous number, like 25 pizzas? Well, that's going to be taking up a lot of memory, possibly. And it's going to cause other kinds of problems too, potential problems. So there's something that's better than an array in one key respect, is that you can add as many items to it as you want. And once you add them, you can delete them if you want. So if you added to the array list of pizzas, if you added 3 items and you decide you didn't want the 2nd item, you could delete it and the list would then have 2 items. Or you could add 4 more pizzas to it and the array list would have 6 items in it. So array lists are expandable. All right. They're not declared at a certain size. They're able to be expanded to whatever size they need to be. So let's look at sort of the modified version of the pizza application where we add in an order class. So I'm going to open up test case, or the unit test. I'm going to open up pizza. And I'm going to open up the order class. The order class is a new one that we're adding in this example. Now, why did they not open? Get this. Yeah. Weird. Now, the pizza class is going to stay the same. All right, because we haven't changed anything about the pizza. Pizza still has 3 attributes: 2 strings, the size and the crust, and a Boolean for whether it has pepperoni. We've written a couple of constructors here. All right, so that we can construct a pizza by either giving it all 3 parameters, 2 parameters, or only 1 parameter. And it will default accordingly. If I only give it the size, it will default the crust to thin, and it has pepperoni as false. If we give it the arg size and the arg crust, it will set the crust and size to the appropriate values, and default has pepperoni to false. If we call this constructor, all 3 of the variables are set by the arguments. Still has a set size, still has a set crust, still has set pepperoni. We calculate the bake time the same way, we calculate the price the same way. So nothing about the pizza class has changed from where it was last week. But we've added a new class, and that's an order. And again, one of the attributes of an order is a list of pizzas. Think of if you were doing a class for automobile. One of the attributes of an automobile might be an array of tires, right? An array with 4 elements of tires. This is called composition, where one class is composed of stuff in other classes. Now with a student, students are associated with a list of courses. So you're going to have in your student class an array list of courses that you're going to use to calculate tuition in the next assignment. So let's look at the order class. It has 3 attributes: a string for the name, a string for the phone number, has a constructor that sets those 2, and it has an array list. Now, in order to use the array list, you have to import this package, import Java util array list. So that needs to be up at the very top of your class. That simply lets Java know that we're using array lists. And when I say array list, I mean the object that's in this package. Now here's a symbol we have not seen before. And that is the greater than and less than and greater than signs done like triangle brackets or angle brackets. What this means is this array list, this list of items, is going to contain pizza objects. All right. One difference between an array list and a plain old array is that an array can contain primitives or objects. Array lists can only store objects. We'll talk about a workaround for that later on, probably not today. There's wrapper classes for every primitive, all right? But for now, we're just going to say that an array list has to contain a class. And we have to define what class that is. So this array list is going to contain a list of pizzas. So the attributes are the name, the phone number, and a list of pizzas. An array list of pizzas. It will start off having 0 elements in it. So this list will be empty. We have our sort of basic set and get method for each of the attributes. We then have three functions that use the array list. We have a function called add pizza. It accepts as an argument a pizza object. That's what this means. Which makes sense, right? Because our array list is an array list of pizzas. So if we're going to add something to the list, it has to be a pizza. We couldn't add a sandwich, for example, if there was a sandwich class. All right. Or we couldn't add a customer to this list. This is a list exclusively for pizza objects. So when we add something to the list, we have to add a pizza object. And that's what this does. This calls the add method on the array list and puts that object in the next available position in the array list. So for example, we start out with no elements in the array list. We do an add to add a pizza. That puts that pizza in position 0 of the array list. All right, that puts it in position 0 of the array list. We call this function again, that puts it in position 1. We call it again, puts it in position 2. Now we don't have the function for it, but we could write something to remove a pizza from the list. That would remove a pizza object from the list, but we don't have that in this example. We're just adding to that array list. We then are going to calculate the price. So what is the price of the order? The price of the order is the sum of the prices of all the pizzas. So that's exactly what we're going to do here. We have a function to calculate price that loops through for I equals 0 as long as I is less than the size of the array list. Size returns the array list size. And we're going to increment I by 1 each time. So if there are two items in the array list, item 0 and item 1, we're going to loop through. The first time through, the variable is going to equal 0. We're going to process pizza 0. Second time through, we're going to add 1 to it and process pizza 1. Is pizza size, is I less than pizza size? Yes, it is, because I is equal to 1 and pizza size equals 2. So we're going to do that second pizza that has an index of 1. Going to process that. Going to come up a third time, add 1 to it. I now has a value of 2. 2 is no longer less than pizza size, so we drop out of the for loop. So this code, written the way it is, allows us to pull out every pizza in that list and add its price to the total. So we declared our total price for the pizza. We loop through every element in that pizza array list. This is how we access an element in the array list, by saying through array list get I. So I, first time through the loop will be 0. I will be 1 the next time through the loop, and so on. So we'll access all the pizzas in the array list. Each time through, we set it to the variable P. Now we're not creating an object because we don't have pizza P equals new object. We're just pointing to this object. What this is saying is point the variable P to the object that is returned by pizzas.getI. Whereas I is the index of the element in the list. So start out it'll be 0, second time through will be 1, and so on for as many pizzas. Then we're going to add to the price of that pizza. So the first time through the loop, we're adding to price the price of the first pizza. We loop again, get the second pizza, add the second pizza's price, and do that repeatedly until we're all done with pizzas. Now, this is alternate code. this one line substitutes for this line, these two lines. And this says, get the pizza on the list and call on it to calculate price method and add price to it. So this actually takes the place of those two instructions. It's just a shorthand. It makes no difference to me which method you would use. They both do the same thing, and they will both sum up the price of every pizza. And then we return that value. Okay, we return the value of the price. Now with bake time, it's a little bit different because we're assuming that you can bake all the pizzas at the same time. I know that's probably not the best assumption, but we're going to assume that we have a big pizza oven so that when we go to bake, if someone orders 4 pizzas, we'll put all 4 of them in at the same time. In which case, the total bake time isn't the sum of the bake time. The total bake time is the highest bake time. So we have another loop, does the same thing, loops through all the pizzas, and grabs the pizza, checks to see if its bake time is greater than the order's bake time. If it is, it sets the bake time to that pizza's bake time. And if this code executes over and over again, when this loop is done, bake time will contain the highest bake time of any of the pizzas on the order. And we return that. Now you might say, why couldn't we calculate the price and the bake time at the same time? And the answer is we could. However, it's good programming practice to have a function do just one thing. All right, function do just one thing. So calculate price is a thing, calculate bake time is another thing. So it's good programming practice to have a function that does only one thing. Now let's look at how this works in action. We create a pizza. We get its size, its crust. Does it have pepperoni? What's the bake time? What's the price? Here's the second pizza. We create that object. What's its size? What's the crust? Does it have pepperoni? What's its bake time? What's its price? We output all that. We then go create a new order with the name and the phone number. And we add those 2 pizzas to the order. So we actually add the pizza objects that we've created to an order. And then we ask the order, what's the total cost of the order? What's the bake time for the order? So let's go and look at what this produces. So we compile it. And then we go and execute our unit test class. First pizza is small with thick crust, has pepperoni. The bake time is 16 minutes. The cost of the pizza is $9. The second pizza is large, thin crust, does not have pepperoni. The bake time is 10 minutes. The prices of the, I have price time there, I should just say price, is $12. So what should the total amount of the order be? 12 plus 9 or 21, which it is. What's the bake time? It should be the higher of these 2 numbers. So 16 is higher than 10. So it will take 16 minutes to bake this order, because we're assuming we're putting in all the pizzas for the order at the same time. So this one these two will bake for 10 minutes together. At 10 minutes, we take out this pizza, and this pizza has another 6 minutes left. Then after a total of 16 minutes, we take out the second pizza and is ready to go. Make sure you study this example. I mean, I went over that. I also have some resources that talk about array lists in more detail. So study through there to see more information about array lists. Now, how are you going to write code for your example? I'm not going to do it for you. Wouldn't take away your fun, but inside your student class, first thing you're going to do is you're going to import that package. You have your class. And you have the attributes. Because what you're going to do is you're going to create a course class. That course class has a name and the credit hours associated with it. Now, right now, you probably have something like this. Name of the student. Residency code. Private. Credit hours. Guess what? We're going to delete credit hours because we're going to determine the credit hours not from some attribute that we set, but we're going to add up the courses that are in the student's list of courses. So we're going to delete that credit hours attribute. So our method right now that says get credit hours that returns credit hours. We're going to get rid of that too. We're going to get rid of the body of the method. And we're going to have a loop. The loop through course array. So instead of having just a number for credit hours, we're going to have an array list that's going to contain courses in it. Now, I'm not going to define the course object. It should be simple enough for you. It's just a simple object that has an attribute of name and an attribute for credit hours. We'll initialize that as nothing. We're then going to have a method to add course. And return nothing. Except the course argument. That's going to add this course to the array list. How do you do that? We showed you in the pizza example. That's how we add something to an array list. Then when we want to get the credit hours, what do? We loop through all the courses, because somewhere here we're going to have a method to get tuition. Or calculate tuition or whatever it's called. Somewhere we're going to say credit hours equals get credit hours. And then we'll use that in the calculation. Under get credit hours, we're just going to loop through, just like we did under order for calculating price. So we're going to add up the credit hours for each course. And when we're done from here, we're going to return the sum of the credit hours. All right. I want to show you how this example, your assignment relates to the example. And again, think of the order as being the student, the pizza being the course. We add pizzas to the order, just like you add courses to the student. To get the total credit hours, we do just like we did to get the total price with the order. We loop through and get the sum of all the credit hours for each course on the list. Are there any questions? Okay, that's all I had for today. I did want to show one other thing. There's a second way to loop through, by the way. There's a second way to loop through array lists. That's using the for each command. And this is done with an array, but we could just as well do it with an array list. For pizza, P, in the list of pizzas, we could do something with the variable I, or in our case, the variable P. Each time through the list, this variable gets the new value in the array list. So some people prefer that method. That's a concise way of looping through all the items in it. All right, if you have questions at all, let me know. I can't emphasize that enough. All right, that if you have questions, let me know. I know that some of this might be new to you, although you've had probably the introduction to C#. Some of this might be different, might be new, but if you're having difficulty, just ask. And I'll do my best to explain it to you, and we can meet online if need be, or we can correspond via email, or we can meet in person during office hours or other times. But if you're wondering about something, please ask. All right, that's all I had today. We'll either see you in lab or see you next week.